So, as he mentioned, my name is Chris Spahr. Christopher is the official name that my mother likes to call me. So, I do national market development for us, for our professional systems division, which is studios and broadcasters and theaters and that type of thing. So, I do the trade shows, like the AES shows, NAB, which is coming up in Las Vegas, which I'm actually not doing, thankfully. It's my job to kind of go out and do these presentations, give trainings, and do a lot of teaching. I'm not the sales guy. I don't know prices for a lot of this stuff. If you ask me prices, I probably don't know within a couple $100 what they are, and it's totally guessing. You can probably Google it quicker than I can think of what it is. But feel free to ask me. I'll just make up some kind of a number for you. So I don't do that stuff. We have sales guys that do that. I come here and do these types of things. I do hands-on presentations. I do demos. I do stuff from people know how to use it, for us. So-and-so's on tour. There's some in your city, and there's a lot of guys who know shows for them. And that's got out there fixing or getting something doing the non-sales. Talk to the future of the audio industry. For me, I went to a school, I took audio programs. It's weird to not talk to kids and take audio programs. Anyways, just my little beef. So what we're going to do today is we're going to talk about digital microphones, and it's a little bit different, and it might be a little techy, a lot techy, and I'm going to try to keep it not super techy. But you guys are going to know or are going to learn enough about normal microphones through the classes that you guys do and stuff, and you've already probably used microphones. These are a whole different beast, and these are the future. And this is why I want you guys to know about them, at least know that they're available, because when you get out in the real world and you go to work for a broadcaster, or you go to work at a studio, or you're going to do an orchestral recording in a live setting, you might start seeing some of this stuff, because we're seeing a lot more of it. So it's extremely cutting edge, even though we developed it about 10 years ago. we were so cutting edge that no one would touch the stuff for 10 years. It scared the hell out of everybody. So this is why I wanted to kind of go over it. And then later, if anybody's going to be in the Pro Tools room upstairs, I guess, we're going to listen to a bunch of this stuff. Listen to the digitals versus the analogs, and hear what the differences and similarities and what's better, what's worse, all that kind of stuff. So to give you a quick background, Sennheiser owns Neumann. So if you're curious as to why I'm here, my shirt says Sennheiser, and I'm talking about both microphones. Sennheiser owns Neumann. Sennheiser bought Neumann 20 some odd years ago. It doesn't say on there. So it's all one big happy German family. Not really, but not happy, but a big German family, let's put it that way. German-owned manufacturer, still run by Professor Sennheiser. Professor Sennheiser is a professor. He teaches at Hanover. He's very big into education and teaching, which is why we do a lot of this, because that's what he does in Germany. And when he calls you and asks where you've been and who you've taught, you have to be able to tell him where you've been and who you've taught. And he does call me, which is a little frightening. Not just the accent, but the fact that it's a Professor Sennheiser. You pick the phone, you're like, oh my God, Professor Sennheiser's calling me. Okay, he's going to fire me. So we own Neumann. We don't just distribute them in the U.S. We used to do that years ago, but now we own them. We also own a company called Klein & Hummel, which is a German speaker manufacturer, which is how we got Neumann speakers. Klein & Hummel, we got rid of the name because no one had ever heard of them. Nobody was buying the speakers because just the name was unknown to anybody in the U.S. It's all the same people, the same engineers, the same manufacturing, the same everything. We are now stamping them Neumann. And now all of a sudden people are buying them. It's a miracle. So, just that one little name change that people know, and now they want to buy the products, which is kind of fun. It's the exact same speakers. Anyways, and you'll hear the new ones, which are very cool. I have them underneath that cardboard bleach box there. And, back up, we also distribute, like I mentioned, True Systems, the preamp, the red stuff there on the stage. We're the US distributor for True, so we don't own them, but we've been dealing with them for a while. They were kind of stamped as the Neumann's microphone mic pre of choice. Neumann did a bunch of tests years ago, asked to kind of give their recommendation for a mic pre that would work with their products. They chose True because True, what's consistent with their name, they're the most true and transparent sounding mic pre. They don't color the sound, and that's what Neumann wanted, something that wouldn't color their microphones. Because Neumann mics are made to sound like a Neumann mic, and then if you stick it through some mic pre that adds a bunch of color to it, all of a sudden it's not a Neumann microphone. It might be cool, but it's not a Neumann. So they chose True because it doesn't add anything, and I have those with me as well, and if we can hook them up later, we'll hook them up and take a listen. So that's why I have the True stuff with me, just so you guys know. So real quick, well, you can see all these things, a legacy of first. Now I'll tell you what some of this stuff is. I don't have my laser pointer.
It's over there. It's on the side.
Oh, you guys have one here?
Yeah.
Oh, look how cool.
The top is a laser. Yeah.
Look at that. Anechoic chamber, the first anechoic chamber for microphone manufacturer. You guys know what an anechoic chamber is? A chamber with no reflections in it. So you can put a microphone, which is what that thing is, in this thing, put a bunch of sound in the room, it doesn't reflect, and you can accurately measure a microphone. We were the first ones to do that. Now everybody should have an anechoic chamber for making microphones, let's put it that way. The first stereo microphone, the first condenser microphone, I mean, the first remote-controlled multi-pattern microphone, on and on and on and on. Neumann developed phantom power. You guys know phantom power? That was a Neumann development. So without Neumann, we would probably eventually have phantom power, but they're the ones that developed it in 1963 or something like that. So, anybody know what the first phantom power microphone was from Neumann? KM84, that's all right. Just figured I'd ask. So a lot of firsts, and you know, they don't want to rely on their legacy and their heritage of making good analog microphones. They don't want to say we make the 87 and that's what we're known for. They're always looking for something new, and they started making TLM microphones, transformerless mics. We were one of the first companies to take out transformers and make the mics quieter and all this other kind of stuff. So they're constantly looking for new, cutting edge. Cutting edge for us is digital now. That's the new thing for us. So that's kind of what we're I shouldn't say just focusing on, but it's a big focus for us, let's put it that way. And once you hear these things, you'll realize why. It's a whole other world of like a sonic picture. It's kind of hard to describe until you hear it. So anyways, so in 2003, we actually helped write the spec for this, and I'll talk about how the digital stuff works. We helped write the spec for it back in 2001, so it's been quite a few years now since the digital mics have been out. 2003, we introduced the first one, this big fat one here, the DO1. It's the Mac Daddy digital. It's the big expensive fat boy. And I have it. Yeah, I have it with me. So switchable large diaphragm. This is the big deal. AES 42. That's what we helped write the AES standard for. Certain way, and they came up with AES 42. So, which I'll talk a little bit about. Just to give you. Have you guys ever heard of AES EBU, like an AES signal, an AES EBU signal?
The connector. The AES. Some of them haven't had my live audio class yet.
Yeah,
it's a connector.
It's on a regular XLR cable, but instead of analog, it's digital. It's sending ones and zeros, just like what's inside your computer. So, and AES 42 is a variation of that. And I'll tell you why it's different and what it does, and why we had to make it different. So. It's cut off at the top of it. It says why digital microphones. I don't know why it's cut off. But. So this is why we did digital microphones. Analog mics, while they're very cool and they have a distinct sound and it might be the exact sound you need, you get what we call bottlenecking, right? You got the microphone, you go to a mic preamp, maybe in here you put in a compressor or an equalizer or something inserted in the chain. Then you go to your analog to digital converter, which puts it in your computer. All of this stuff reduces that signal that the microphone initially saw. So if you're recording a waveform that's this big, your microphone sees it, hits your mic preamp, it cuts it down. Hits a compressor, it cuts it down. hits the A to D converter, cuts it down even more. So there's level mismatches, there's impedance mismatches, there's noise along this whole analog chain. Now the resulting, what you get in your computer and what you're hearing might be exactly what you want, and that's cool. If that's your vocal sound or your guitar sound, fine. It may not be exactly what you heard in the studio or what you're recording, but it's ultimately what you wanted, which is great. Digital doesn't do that. Digital takes all of this stuff out, all of the mismatches, all the noise, and exactly what that microphone hears, this signal, is exactly what you get in the computer. It's an exact sonic picture of what's happening in the studio. And again, whether that's good or bad, that's up for you guys to decide depending on the application. But that's what it does. It eliminates all of this other junk, for lack of a better word. It could be good junk, but it takes it out. Let's put it that way. So the digital signal flow, it's a lot different. So that stuff is flying in everywhere, man. So instead of going, microphone to preamp to maybe a compressor to an A to D converter, here's your microphone, which has your analog to digital converter in it. Right from there on, it's digital. At that point, as soon as the sound hits the capsule, it immediately gets converted to digital because the A to D converter is living in the microphone right behind the capsule. And from there on out, it's digital. So you can kind of do whatever you want with it. So you can turn it into optical, MADI, all these different digital interfaces. So right here, fewer opportunities for any of these issues, any kind of mismatches of level and noise and sound degradation. The A to D converter that we use is a Neumann A to D converter. That's kind of the key, that's the magic in our microphones in particular. There's only one other manufacturer that makes a digital microphone like this, and it's Schoeps. And I mentioned them before because they helped us write the standard. Schoeps makes only a couple of options of digital microphones. We make a lot more. Theirs are made very different, and they don't use our converters, of course. I don't know what converters they use. We use a Neumann A to D converter. It's tuned for the actual particular microphone that it's in. It's a 28-bit converter. I'll talk about it some more. It's the magic behind why these things sound the way they sound. They're awesome. So I'll keep going so you guys are super bored, but I should still have more stuff on the page. So AES-42, why we did it and kind of what it is. So I keep pushing these buttons here. Computer's acting everywhere. Okay, there we go. AES EBU is the normal AES signal, right? It sends digital audio. We needed to do more than that. We needed to send digital audio. We also needed to send control data so we can talk to the microphone and it can talk back to us. And we needed to send phantom power. I mentioned phantom before. Phantom power is regular analog microphones. These things need phantom power as well, but it's digital phantom power. The normal AES spec wouldn't do that, so we had to, again, these manufacturers got together and figured out a way to do it. Using the same cable, it's the same XLR connector. You can use a regular old mic cable from the live sound class. It doesn't have to be anything fancy. And I have digital cables with me, but you don't have to use digital cables. But by making this AES-42 standard, we can now have digital phantom power, so it sends voltage down the cable to the microphone, making it work. And we can send data back and forth. So I can tell the microphone to change polar patterns from a software program. I can tell it to pop in a high-pass filter, pop a compressor in, raise the gain, lower the gain, whatever. And it tells me also, back at my computer, what microphone is plugged in, the latency, because you see how long it takes for the audio to go to the mic and then back again. And we're talking samples of latency, super low delay, so you don't actually hear it. This is why we wrote AES-42, because we needed all this control. We needed to be able to put the microphones on the stage and sit in front of house and control them remotely. Because we weren't using a normal console anymore. We're not going to a mic pre with a knob that you can turn. We needed some way to be able to control the gain on those things. So that's what we did. And it complies with this AES EBU standard, so they're intercompatible and all that kind of good stuff. And there are other companies that do this. I mean, ourselves and Schoeps are the only mic companies that make this. There are other companies. Digico does live sound consoles. They have AES-42 consoles now that take our microphones directly. A company called Innovason, which is a French console manufacturer,